In this section, we'll explore how we'll manage files in Git using Visual Studio Code. With Ansible, we've discussed how we want to take advantage of the concept of infrastructure as code, meaning that you describe the environment and architecture of your deployed ecosystem in code so that you can then use that to deploy or even redeploy your environment, eliminating human error and increasing both productivity as well as reusability. Since you are going to express your work in code, we then need to consider where does that code live. And as an industry standard that I've mentioned before, Git is a common go-to. In our case, we're going to use Git, and Git is a distributed version control system, meaning non-centralized, so that you can have teammates work on various bits of the code base that you own and manage, and then share that work with one another. Using a version control system has a large number of benefits. It allows you to assess and review existing code, to make changes and adaptations of that code, review it and send it back, restore or roll back changes that may or may not be appropriate, and a suite of tools to be able to approach how you need to manage your code as a team. Maybe certain team members work on certain components to your code base while other team members do others. And in an Ansible ecosystem, that makes a lot of sense. You may have team members who manage the Ansible workloads that instantiate or provision your environment, where a totally different set of the team works on the code base that deploys the application. And all this needs to be housed in a single code source that we'll use Git for. Some terminology to know around Git is necessary to begin working with it. And the first thing to think about is Git collection of code is called a repository. So in this course, we'll certainly use several repositories to manage our code base. When you have a repository, taking a copy of that repository's code is known as cloning the repository to get a localized copy from the source itself. Everyone who works with a code base will clone that code base to their workstation, make whatever adaptations they need to, submit that code back using the tools that Git provides. Review, merge, and such will be vocabulary used in this workflow. When you do take a clone, you now have a working tree that is your own, which is a collection of the files you inherited, as well as now the files you'll continue to modify or even add to the code base. Once you've finished making your changes, the concept of a push is necessary to send your code changes back into the main source, the origin of the source code or repository. So, sending a push will send your changes back up the tree. Now, if other team members are making changes as well, you need to get those changes, and that's known as a pull, receiving those changes from the source. When you do a pull, what will happen is you will reach back out to the origin, your Git repository, and retrieve any changes that you don't currently have. All of these changes are tracked with versioning so that you can roll forward or roll back should a change be inappropriate to other points in time in the working tree. When working with files, you have a few statuses that a file will be in. Modified would be a file that you've pulled from source and made changes to. A staged file is a file that you've modified that now has been readied to push back upstream. And then a committed file is a modified file that's been added to the local repository. Once you have your local repository ready for a push, you'll then proceed with the tools to be able to send that back into the origin. You can see in the diagram here that you have your working directory here, and that's a local directory on your machine. You make some changes to add some files or adaptations to existing files that you'll then need to stage. From there, you'll need to use a commit to add those files to your local repository, making them part of the code base locally. And then you'll need to do a push to send those files back up to the origin, the remote location where all the source code lives. Some other keywords to recognize are a reset. Reset allows you to throw away your changes and go back to the origin source that you started with. Resetting a commit removes those bits of the commit and lets you restage them if necessary. Pull, we mentioned a bit earlier, is a gathering of the files you do not have from the source and bringing those into your local repository, your working directory. And a fetch will actually take the files that you're missing from the remote and bring them into your local staged repository. Now, that's great to know these bits about Git, and we'll certainly see that in this course, but how we'll actually manage our code base is using a tool called Visual Studio Code. Visual Studio Code is what is known as an IDE, an integrated development environment. This is a tool that allows you to author and edit code, as well as has integrations with our Git repository. You can see some links for documentation, as well as a place where you can get a copy of Visual Studio Code for your own usage. With Visual Studio Code integrated with our Git repositories that we'll use, that's how we'll perform our work in this course. Authoring and editing Ansible files, creating commits and pushing them back into our repositories, and then leveraging those repositories within Ansible Tower to perform work on the managed hosts we've created in our inventory. You can see in our documentation a bit about installing Git on Microsoft Windows. You'll certainly want to do that, and you can get that online, and you see a walkthrough of that installation. And once you have that, it's important to go ahead and launch the Git graphical user interface. Once you do, you'll get to a screen that allows you to configure the Git behaviors as you see appropriate for your needs. And the main ones to call out that we'll care about is that it does allow here for the creation of credentials to your repositories. Since we are going to be using Visual Studio Code and it has integrations for our Git repositories, we'll be able to make the same kinds of configurations there. Once you have Visual Studio Code installed, you can navigate into the settings and find the extensions area. Once you do, you can go ahead and find the area for path, which will explain where the Git executable is. By default, you can see the path located there where Git would by default be located. But if you've adapted that during your installation, you'll need to update that so that Visual Studio Code knows how to find the Git tools necessary for its integration. Here you can see if we needed to edit that path, where we would do so and what that looks like. And a key note to call out here is that if you are including backslashes in the path to a file, which we would do in Windows every time, you'll need to escape those as this is JSON code. So notice that all of these various bits here that we have a double backslash. One of the backslashes being appropriate to where the path is, and the other being the escape character to denote that these are strings and not to be interpreted. Lastly, while we've not talked about the language we use to author Ansible yet, we'll be using YAML, Y-A-M-L. And so for Visual Studio Code, we'll want to add the extension for YAML to make sure it does native syntax highlighting and checking to make our work even easier. You can navigate through from View to Extensions and install the YAML extension. Additionally, you can clone Git repositories in Visual Studio Code by using the command palette. You can either navigate there by clicking through the View menu or using the hotkey Control-Shift-P to launch the command palette. Once you do, if you type git clone, that will give you access to the command to clone a Git repository, at which point you'll just supply the URL for that repository, which will be included in our lab instructions. Here you can see an example of pasting in one of those Git paths so that we can clone that repository. Now that we have an integration from Visual Studio Code to Git and have added the YAML extension, it's time to start working with files. Throughout the course, we'll do this where we clone a new repository, manage and edit some files, either edit existing files or even create new files. And we'll need to understand how to use Visual Studio Code to properly add those back into our Git repositories. Once we have a repository cloned, you can open that, and I believe the Visual Studio Code will prompt to do so automatically as soon as you clone a new repository. You can either click that button or use the File Open folder and navigate to where you've placed those files. Once a repository is open, you'll have access to the files in this area, and then as you click on a file in this area, you'll have the contents of that file displayed for editing. Some important indicators to call out are at the bottom of the screen. You can see this area here has a series of icons that denote which branch you're referencing back at the source, as well as if you're ahead or behind or changes need to be synced. And this button here will allow for you to sync those changes. When adding a new file, as is being shown in this illustration here, you can see that we're creating a new file and we're calling that file site.yml, and that is opened in a new tab, and you could have multiple tabs here depending on how many files you have open to click through to navigate between the files. As you have a file open, the contents of that file will be displayed with line numbering here, allowing you to edit and alter that file. Now, some things to notice from a Visual Studio Code perspective are some icons that indicate the status of this file in relation to the source repository, your Git repository. In this case, if we're creating a new file, the file is unknown to our repository, so the concept of an untracked file is denoted with U. And our site.yml is certainly an untracked file at this point. We can see that U listed here and on the same thing here. What we'll need to do to ready that file for that source control upload is to handle that. And Visual Studio Code gives you the ways to handle that. You can see in the next screen the set of tools that are available to you here to add that to the repository and track those changes going forward. In this table, you can see the various annotations Visual Studio Code will use. We're calling out the untracked in this example, but there's also a file that is already being tracked that you've made changes to, will be denoted with an M for modified. A file that was untracked that you've now added will have an A for added. And a file that was previously tracked that you're removing from the repository will get a D for deleted. If you click that plus sign next to the site.yml, you will then add that, and you can see that down here we've now changed that U from an untracked file to an A as an added file. This means it will then be synced to our repository once we do so and tracked going forward. Now that we have added that file, you come back down to this bottom bar here and you can see that we have an update showing that we have one file locally that is not in the remote repository. It will be required for us to click the sync button here to go ahead and synchronize those changes, sending our new added file back into the repository upstream. And once you do, you'll get this status box asking, would you like to push and pull commits to and from the origin or master branch of this repository? Saying OK will allow you to do so. And now you've committed your changes back upstream to where your other team members can see that work and leverage it going forward. This concludes this section of our content. Please continue into the guided exercise, and I'll see you again once we visit the solution.